fx dx. So this is the result we obtain. Now we are going to extend this result for n intervals. Here we have used only x0 to x2, so we are going now to write it for the n intervals. So here, by using the same property of the integrals, splitting it into the subintervals, we can write it in the form of x0 to x2 fx dx, x2 to x4 fx dx, similarly x4 to x6 fx dx, and many more results you can write down xn minus 2 to xn fx dx. So this is the distribution or the splitting of the integrals into the subintervals of length 2 each. And now we are going to replace these integrals with this result. So here, on substituting, this result for the first integral will be having h by 3. Inside this gives you y0 plus minus 4y1 plus 2 y2. This will be plus sign here. 6 is with the plus sign. So the next will be on replacing this on the similar pattern for the interval x2 to x4. We can write down h by 3. Inside this gives you y2 plus 4y3 and y4. Next is h by 3 for this integral. It starts from x4 to go x6. So here we write down y4 plus 4y5 and y6. And if we keep on writing on the same pattern, so the last integral can be replaced by x yn minus 2 plus 4 times yn minus 1 and yn. So here we have replaced all these integrals, the results like this. And after this, now we have to simplify this ultimate result. First of all, if you go through it, we get h by 3 as a common factor. Now looking inside, we'll see the first and the last term remains unchanged. There is no, and these are appearing only once. But whenever we go through the other terms, look at this term and all these odd terms. These are odd terms, we can call them odd terms. These are appearing with a multiple of 4. So we write them as y0 plus 4 times y1, y3, y5, and keep on writing up to yn minus 1. And all the other terms, which are the even terms, you can see are appearing, this is y2 only, not 2y2. So all these are appearing twicely. So here you can see these are appearing twicely. So these are going to be multiple of 2, y2, y4, y6, and so on. And the last term as it is. So this is your second formula, which is named as the Simpson's 1/3 rule. This is your second formula. So far we have derived two formulas, one for the trapezoidal rule and second for the Simpson's 1/3 rule. Now we are going to construct the third formula, and that is of course about the Simpson's 3/8 rule. The principle of deriving this formula is almost the same. So here let me write down the construction for the Simpson's 1/3 rule. So for the Simpson's 3/8 rule, Here we put the restriction. In the Simpson 1/3 we have truncated it up to the second order difference. Now we are going to truncate it up to the third order difference and taking the limits from 0 to 3. Okay. So here we write down the result x0 to x3 fx dx. On the right side it goes to p y0 p square by 2 del y0 plus 1 by 2 p cube by 3 minus p square by 2 delta 2 y0, and one more term we have to write down 1 by 6 p4 by 4 p cube plus p square into delta 3 y0, and the limits are from 0 to 3. We have truncated this series up to this order of difference, and using this limit from 0 to 3 we can write down in the form of the sentence as well. Okay, after doing this, now if you apply the limits, we get 3 times y0 plus 9 by 2 times del y0. From here we get plus 1 by 2. 27 by 3 gives you 9 minus 9 by 2 into delta 2 y0. From this we get 1 by 6, 81 by 4 minus 27 plus 9 and delta 3 y0. So here we have applied the limits from 0 to 3 and we got this. Okay, and that's fine. Now you have to simplify. I hope you can do all these simplifications of yourself. I'm writing the results directly. So here we have after the simplifications result. So I'm going to read it because I have used for all these three formulas, so there is no more need of it. We can erase it. So the result takes in of form h outside always there. There is 3y0 and plus 9 by 2 delta y0. From here we get plus 9 by 4 and delta 2 y0, and on simplifying this we get plus 3 by 8 and outside there is delta 3 y0. Okay, you can verify it. Might be there is slight error, but of course the procedure is the same. Okay, now after simplifying and we obtaining this result, the next step is to replace these differences. We have already replaced these two differences with the simple algebraic functions. So now we are going to replace this one as well. On replacing them, we get 3y0 plus 9 by 2 into y1 minus y0 plus 9 by 4 y2 y1 and y0 and plus 3 by 8, and this result is after this is the third order forward difference. On applying we get y3 let me write it here, 3 by 8 y3 minus 3y2 plus 3y1 and y0. So this is the third time operation of the forward difference operator. You can verify it of yourself. There is nothing difficult in it. Okay, now the next step is to simplify all these terms and collecting the like terms together, and ultimately whenever you simplify entirely, you will be having the result of the form 3h by 8 outside. Inside there will be y0 plus